friends. In today's episode, we shall take a look at this question which we have over here. This is actually a WAEC question, and question 19 and 20 OBJ from the year 1996. So if you have a WAEC past question and you have attempted questions from this year, probably you should have encountered this question. Now this question is going to be something we shall use to continue our last episode. So we already established the fact that the area of a sector, call it sector 1, to the length of the arc of that sector will always be equal to the area of another sector 2 to the length of that sector, provided that both sectors are in the same cycle. The same cycle. So if this sector 1 and this sector 2, this law can actually apply. Question 19, I'm going to read it out, so if you are taking down your notes, you can simply take down. So we can see the diagram here. The question says use this diagram to answer question 19 and 20. And question 19 says, what is the length of the major arc? What is the length of the major arc PAQ? Now WAEC is even lenient enough to give you an insight or a clue as to how you can locate the major arc. That's why they said PAQ. And the next question, question 20, says what is the area of the minor sector POQ? What is the area of the minor sector POQ? POQ, PAQ, you can use them to identify what particular line or what particular shape they are referring to. Now since they said PAQ and they said that's the major sector, in our previous episode, I think last two episodes, I explained practically what a sector is, what a segment is, what a chord is. Now if you had followed that episode very well, you will agree with me that this is an arc, rather not a sector. That is an arc which I've just drawn the purple line, and this is also another arc which goes all the way down here. So that means we're having first arc and second arc. Now which of them is the major arc? The major arc is the longest. So you can see that arc 2 is the major arc because it's the longest. Now we are asked to find what the length of that major arc, and you can see that major arc is formed by what points? P, A, Q. That's what WAEC said, arc PAQ. Hope that's clear. And next we're asked to find the area of the minor sector. Now we have two sectors. I've defined what a sector is in the last two episodes, so if you have not gone through the last two episodes, just go through the episodes I released first on this concept of measurement. If you are joined the group newly and you need those episodes, please just signify so that I'll resend them to the group chat or forward them to you privately. Now we have two sectors. The first sector which we have is this sector 1 and sector 2. Now which of them is the major sector and which of them is the minor sector? Major is always the biggest and minor is the smallest. Now you can see that the angle of this sector is what, 60 degrees. That's the angle of the small sector, and then there's another angle here, angle O. Now we can evaluate that angle O by simply understanding that the angle at a point is always equal to 360 degrees. So if the angle at the point is 360 degrees and then we're already subtracting 60 from it, which is the angle of the minor or the smaller sector there, we'll be left with what, 300 degrees. So it means angle O is actually 300 degrees. That's the biggest angle, right? And any sector that has the biggest angle is always the major sector. Now we have identified our major sector as this sector and our minor sector as what, that sector. Good. And then we are asked in question 20, what is the area of the minor sector? So I've done this so that you can know what we're actually solving for when we begin the solution. Alright, so that's it. And the diagram again gives us something like this, and we're having an angle here which is 60 degrees, and we are told that this radius is 3.5 centimeters. Okay, now first of all we need to find the length of the arc. Now I'll need to note this: the formula for length of arc is quite similar to the formula for the area of the sector, but there's a little difference. Now length of arc is gotten from the fact that we have the circumference. Circumference is 2 pi r. That's the circumference, 2 pi r. Now when we multiply this by what? Theta over 360, because we are trying to say what is the circumference around that sector. The sector is simply a portion of the entire cycle. A portion of the entire cycle is simply a part cut out by 2 radii, creating an angle like this. Now this portion, which we call theta, if we are to look at the portion of this cycle, out of the overall angle of the cycle, the overall angle of the cycle, angle to point, is what? 360 degrees. Now if we are considering a ratio of what? This portion, a portion, if we are taking a ratio of this portion to the overall full cycle, we call it theta over 360. Now this ratio is in terms of angles, right? So whenever we are looking at the ratio of a particular portion of a cycle as compared to the overall portion, the overall angles of that cycle, we are looking at the ratio that is formed as a result of a sector, right? Good. So we're looking at a portion formed by that sector. Now the circumference bounded by that sector, or the circumference with which that sector actually covers or captures among the full circumference of the cycle. This is the full circumference of the cycle, like this. Now the sector we are talking about is this one. This is just the portion. The full length is 2 pi r. That's the full length of the full cycle. So how do we get that portion that is bounded by, or that is cut out by that sector? We get that full length by multiplying that 2 pi r with the ratio of angles which that sector actually cuts out, which is theta over 360. You understand? So that is how we calculate for the length of the arc. So it's not something you should be cramming. Don't cram the formula. Just understand this simple thing which I've just explained now, how you can get that formula by just understanding that the sector cuts a part out of the cycle, and that part which is cut, when we look at that part in terms of the angle, when we place it in a ratio with the overall angle, we will say theta over overall angle of the cycle, which is 360. That is the portion of the sector. And now we're not seeing that this portion of the sector, which is theta over 360, what is the circumference of that portion? So we multiply that with the overall circumference. We multiply that with what? With the overall circumference. That will now give us the portion, exact portion. That will now give us the exact portion which that sector takes out of its overall circumference, which is just this area in pink. So that's why our formula is always length of arc LA equals 2 pi r theta all over 360. Now the formula for the area of the sector is similar. How do we get the area of the sector? Going back to the sector which I drew here, we are having this portion as a sector. If we are to find the area, usually the area of a cycle is what? Pi r square. That's the area of a cycle, pi r square. Now we're not just finding the area of the overall cycle, but we are trying to look for the area of this particular portion. again, the only way we can relate portions in cycle is by their angles. That's where we can actually describe portions in a cycle, is by their what? By their angles, because the cycle is all about angle. A full cycle is full 360 degrees. So cycle is all about angles. So the only way we can relate portions or describe portions in a cycle is to describe them based on their angles. So if I were to talk about this particular portion now that have been shaded, the area of that portion will be simply a fraction of, this is a fraction of the overall cycle. The fraction of the overall cycle again is what? Theta over 360. That is the fraction of the overall cycle, right? The fraction of the overall cycle is theta over 360. Now if you want to get the area of that thing, we are saying what is the area? Area is pi r square. We are saying what is the pi r square of this portion, which is theta over 360. That's what we're asking. What is the pi r square? The area of what? Theta over 360, because we're talking about cycles here. Now when we convert this off to times, what will it give us? It will give us what? Pi r square theta over 360. This is why you should not cram. Strive not to cram your formulas. This is what we do at the Detailed Learning Institute online. We try to help you find ways in which you can learn without cramming, and then you can understand several concepts by just knowing them, by understanding them, and you don't really need to cram them. Now this is the formula for area of what? A sector. Pi r squared theta over 360. So it's quite similar to that of the length of an arc. The formula for length of an arc, we have said that formula is this very one, and then the formula for the area now, area of a sector, is going to be what? Pi r squared theta over what? 360. Good. Now right into the solution to this very question. For question 19, we can find the length of the arc in two ways. The first way, which is the shortest, is to adopt the formula directly. Now to adopt the formula directly, we will simply put in the values. Pi is 22 over 7, it's a constant, and the radius is given to us in the question as 3.5, and the angle of the major sector wasn't given to us, but since we understand that the full angle of a cycle is 360, since this part is already 60, then this other part will be what? 360 minus 60. Yes, that is 360 minus 60. That would be what? 300. So that's how we know that the angle of that very sector which has the major arc will be what? 300 degrees. So we simply impute these values into the formula. 2 times 22 over 7 times 3.5. Okay, I'll bring this down because of the space, but make sure they're on a straight line in your own. Divided by what? 360. Divided by 360. And now when you are solving this with your calculator, make sure you actually solve out the numerator first and place the value for the numerator divided by 360. This is what exactly will give you the correct answer. But I'm going to write the answer directly now, not breaking, but you have to do it like this when solving, so that you will have your answer actually correct. Or you can actually solve it directly by using the fraction button. There's a fraction button in your scientific calculator which is actually like this. It's somewhere around the top left hand side of your calculator. Hope your calculator has that. It makes it easier. So you can activate that button, and then you are going to impute the numerators all at once, and then you impute the denominator, and it gives you a value 18.333, and so that's the answer. Or you can go gradually. By saying 2 times 22 over 7 times 3.5 times 300, and this gives you 6600 as your numerator. And then you write it down, and then you do the denominator, which is you have as 360, and then eventually you have 600 divided by 360, and you can see you have the same answer. So those are the two ways you can resolve this fraction, and eventually you will have your answer to be 18.33 cm.